Okay, so let's do some more with parametric equations. Yesterday we practiced learning how to convert back and forth, and now we are going to learn how to graph. So you can go back to page 119 in your book, and we're going to start with example 1. So they give us two equations. We have an equation that says x equals right here, and an equation that says y equals right here, and they gave us a restriction. So I'm going to use this restriction to make my table. And instead of making a table that is only 2 across, I'm going to make a table that's 3 across. So I'm going to have a t value that I'm going to plug in. And when I plug my t value in, I'm going to get an x value. And then I'm also going to get a y value. It says that t goes between -2 and 3, so I'm just going to go -2, -1, 0, 1, 2, 3. And I'm just going to plug these t values in. So I'm going to take right here my first value. I'm going to plug -2 into my x equation. So -2 squared is 4. 4 minus 4 is 0. I'm going to plug the -2 in to my y equation. So -2 divided by 2 is going to make a -1. And I'm going to keep going. So -1 into my x equation. -1 squared is going to be a 1. Minus 4 is going to be a -3. -1 divided by 2 is going to be a -0.5. 0 squared is 0. Minus 4 is -4. 0 over 2 is a 0. 1 squared is 1. Minus 4 is a -3. And then I get a positive 1/2. 2 squared is 4. 4 minus 4 is 0. And then 2 divided by 2 is 1. 3 squared is 9. 9 minus 4 is 5. And then 3 over 2 is 3 over 2, or 1.5. On my graph, however, I only have an x-axis and a y-axis. So I'm not going to graph the t. I'm only going to graph these two things. It's the time that I plugged in that caused these x and y values to occur. And I'm going to graph them in order. That's why I made my table in order. So the first time that I plugged in, or the parameter, was -2. So I'm going to go graph 0, -1. And then I'm going to go graph -3, 1, 2, 3, -0.5. And then I'm going to graph -4, 0. -3, +0.5, 0, 1, and 5, 1, 2, 3, 4, 5, 1.5. The only thing that's different about this graph compared to every other graph that you've ever drawn is this graph is going to have an orientation, a movement on it. And so let me connect the dots. I connected the dots in the order they were graphed, in the order they appeared due to my time, my parameter. So you're going to draw what's called orientation arrows around the graph. This tells us that when the time occurs to make this graph happen, when time is passing, then I move in this direction. So the only difference is we have to draw the arrows. So now I'm going to let you try example 2, but I'm going to get you started. Example 2 is very similar. It says that x equals 4 minus t squared minus 4. Oh, no, sorry. I totally wrote that wrong and read it wrong. Let's try that one more time. X equals 4t squared minus 4. Y equals t. And then it says that this time my t is between -1 is less than or equal to t is less than or equal to 1.5. So make my table again. T, x, y. We might need a calculator for this one. We'll see. But I'm going to go by halves this time because to go from -1 to 1, I only have 2 dots. So let's start at -1, -0.5, 0, 0.5, 1, and then 1.5. Let's try those and see what happens. So go ahead and pause the video, complete the table, and draw your graph. Okay, so I went ahead and finished my table, and I'm going to go ahead and graph these dots. So 0, -1, oops, 0, -1, -3, -1/2, -4, 0, -3, +1/2. Man, these seem really familiar. Let's see. 0, 1, and then 5. 1, 2, 3, 4, 5, 1.5. Then don't forget your orientation arrows. We went in this direction. And I'm hoping you are thinking, man, this looks like what we just did. And it is exactly what we just did. And that's because based on the time, the restrictions of the parameter, and the two equations, we can take any rectangular equation that we have and make the exact same parabola. And I want to prove that to you real quick. This one says that y equals t. So I'm going to plug that in. So instead of writing t, I'm going to write y. So x equals 4y² minus 4. Or we could have said that x equals, pull the 4 out, y² minus 1. And you can use your rules of parabolas from conic sections from last chapter, and that graph is that equation. And if we convert the other one, we're going to get the exact same thing. It's the t/2 and the 4t in the x and y equations that cause it to be the same. So parametric equations may look different, but they might make the same exact rectangular graph.